Hello and welcome to day 2 of digital learning. Today we are going to focus on compound experimental probability. And so our goal is being able to find compound experimental probability. Now, when we talked about compound probability earlier, we had all that fancy stuff of the probability of A and B is equal to the probability of whatever A is times the probability of B. Great news. Don't need to do that. So that's for theoretical probability. But for experimental probability, we're more curious about a table. So let's say we have a table that looks roughly like this, and you have a couple of options. So up here you have options A and B, and then you have options C and D. Experimental probability is similar to this part right here, or compound probability that is, where we're going to still ask about what's the probability of A and maybe in this case, D. In order to determine what that probability is, we find the boxes where that overlaps. So that'd be right there. So that will tell us that's one part of what we need. What we'll have to do is find out what all four of these add up to, 3 and 4. And so the premise is still very much the same. We're talking about the number of events that we want over all the events. So we'll still have to add some stuff up to figure out what the denominator is, but then we just take this number and plug it in there. And then as always with fractions, if we can, we simplify. So let me show you so that way we can kind of see what this looks like. So here's an example from the textbook. It says a food trailer serves chicken and records the order size and sides on their orders as shown in the table. What is the experimental probability that the next order is for 3 pieces with coleslaw? So we're talking about 3 pieces. We're talking about coleslaw. We have to find where those intersect. Okay, so 55. That's a key number. Now, what we have to do is all the tedious work of adding up all of these numbers. So 33 plus 13 plus 22 plus 55 plus 52 plus 65 plus 35 plus 55. And what that happens to be is 330. So again, I got 330 by adding all those numbers up. Now, take a look at the fraction. That fraction can be reduced. So we can take a 5 out at least. Take a 5 out. And then we'll end up getting 11 over 66. So that's from taking a 5 out. So that gave us 11 and 66. Taking a look at it, we can reduce this even further to make it 1/6. So that is our experimental probability. Again, what we have to do is focus on the one part of the table or the data where it overlaps, the 2 things we wanted, coleslaw and 3 pieces. Then take that number, put it in the top part of our fraction, add up everything up, and put that in the denominator. Let's look at one more example. Drink sales for an afternoon at the school carnival recorded at the table. What is the experimental probability the next drink is a small Coke? So, just like last time, we need to take a look at where they overlap. We want small and Coca-Cola. I'm not quite. You can tell that sometimes these books are written for the whole national audience and not necessarily using the words we would use. Oh, Cocoa. Oh, that's what that. Anyways, well, that's what we're looking for. And that overlap is at 60. So we end up getting 60. Now, the denominator, we got to add up all those numbers. 77 plus 68 plus 98 plus 45 plus 60 plus 52. Did a little magic on the side, and that's equal to 400. Okay, and now got to reduce that right off the bat. You can obviously take off a 10. We're looking at 6 over 40. You can take out a 2 to get 3 over 20, and that's as far as we can go. So in a nutshell, that is experimental probability. The premise is still the same. The number of desired events over all the possible events. It's just how do you extract this from data? And then when someone asks, what's the next one going to be? You just use that number right there. Right? As it stands right now, the next one has a probability of 3 over 20 being that thing. So your homework is to do a widget. Again, it's the worksheet for this section. This time I've enabled the check mark, so that way if you're getting it right, you know. Make sure you're reading, you're taking your time, and you're reducing your fractions. But besides that, I think you guys should be good to go.